So, we will continue about multi-electron atom. Okay. So, we have seen the structure of atom, basically how these energy levels for electrons are available in a atom. So, apart from the discussion on single electron system, means if one electron is put in atom, so it can be at any energy level. So, but what will be the minimum energy for the atom? So, that is called ground state, and that one has to find out. That we know that for minimum smallest n and smallest L, the energy of the system will be a minimum. Okay. And energy level is basically, we have seen this energy E and L, it depends on N and L. Now, so we have enough discussion for one electron in atom. Now, if I put one more electron in second electron, then third electron, fourth electron, so it will, so it define the basically different atoms, helium atom, lithium atom, then beryllium, boron, carbon, neon, right. So, chromium, copper, etc. Okay. Depending on the number of electrons in the atom, so it is a different name of atoms. So, we are interested to find out the spectroscopic term for multi-electron atom. So, to find out the spectroscopic term, I need L and then S and then J. Okay. So, for single electron this is fine, we have discussed. Now, for multi-electron, if I want to find out, so I have to take help of vector model. So, for already we have discussed that what will be the resultant angular momentum, orbital angular momentum, that is for multi-electron system generally we write capital L, and what will be the resultant spin angular momentum. So, that for multi-electron atom, so that we write by capital S, and then what will be the resultant this J, means from L and S, due to LS coupling we get J. So, what will be the resultant J? J also we get from the JJ coupling also, as I mentioned earlier. So, but here we will consider LS coupling, because most of the atoms they shows this LS coupling rather than JJ coupling. JJ coupling generally is found for heavier atom, means high Z value. So, that we will not discuss now, but mainly we will consider LS coupling. So, that is our aim to find out. So, as I see in general, and also I have shown that electronic configuration of multi electron atom, and it is 1:2 for any number of electron, you have to distribute electrons in different orbitals. So, that orbitals I have mentioned earlier. So, this let me write here just one is, then energy wise this is the smallest energy, 2s, 2p, 3s, 3p, 3d, right, 4s, 4p, 4d, 4f, right. So, this a 5s, 5p, 5d, 5f, 6s, 6p, etc. Okay. So, and how we distribute electrons, so that I have mentioned that this just we follow the building block principle or Abbaugh principle. So, this one can fill up the electrons, multi-electrons in the orbitals. So, and also we know that how many number of electrons can it can this s orbit can take, it is 2. So, this S2 in general whatever the n, it does not matter. So, for S2 then P6 D10 okay, F14. So, this is the maximum number of electron these subcells, these orbitals can accommodate. So, these are called closed cell, closed subcell. It is called closed subcell. So, a closed subcell and closed cell, it is you see when this n principal quantum number, depending on principal quantum number, this it has two subcells. If this whole cell is filled with the electrons, so then that will be called this closed cell or closed subcell. So, this has importance. So, this distribution follows the Pauli exclusion principle. It is fine. Now, as I told that I am interested to find out the spectroscopic term for multi-electron atom. So, this would be say I have to find out capital L, capital S and capital J. So, let us for one electron, that already I have seen in s orbit, say if s orbit 1 electron. So, immediately I will write its what is the n equal to 1, 2, 3 whatever, that we are not considering. So, just if so S means L equal to 0. So, L1, let me write L1 equal to 0 and this 1 electron is there. So, S1 is half, right, S1 is half and this is fine. So, its spectroscopic term for 1 electron, it will be basically this L is 0 means it will be a spectroscopic term, it will be for this case is equal to 1 spectroscopic term. Here I can write, I will write here. So, S and then S is half. So, it is 2 and then J will be L1 plus S1 or L1 minus S1. So, here it is take only positive values. So, it is half. So, So, this will be the for S electron, 1 electron. So, that will be the spectroscopic term. Now, if you take 2 electron, if you take 2 electron S, so it is put in S orbitals. So, now I have 2 electron. So, L1 equal to, so basically L1 equal to 0, S equal to half, that for 1 electron it is there. So, now for additional electron, so this L2 is 0, S2 for second electron it is half. Okay. Now, 2 electrons are there, it has angular momentum, orbital angular momentum L1 and L2 both are 0. So, using the vector model, what will be the resultant L? What will be the resultant L? That is say capital L, it will be 0 definitely. Okay. L1 plus L2, 2 L1 minus L2, that is the vector summation of orbital angular momentum. And now I have spin S1 half and S2 half. Now, what will be the resultant S? So, resultant S will be S1 plus S2, 2 S1 minus S2. So, it will be basically S1 plus S2 magnitude this 1, S1 minus S2 magnitude is 0. So, basically it will be 0 and 1. Okay. So, it will be 0 and 1, and now here we have to see whether if I take this S equal to 0 and 1, whether it satisfy the Pauli exclusion principle. So, Pauli exclusion principle, as I told earlier, that NL, ML and MS. So, that has to be the set has to be different from the different for each electron. So, so here L equal to 0, total L equal to 0. So, L1, L2 these both are 0. So, ML obviously is 0, ML for this ML. So, generally we write sum over ML equal to what is there, ML1 plus ML2. So, both are 0. So, they are obviously for 2 electron 0 plus 0. Okay. That means ML1 is 0 and ML2 also 0. So, now N is same, L is same, okay, for both electron, and ML also same for both electron. Okay. So, MS has to be different for these 2 electrons, MS has to be different. So, there is no choice that MS has to be for this case. So, here I can think. So, MS yeah, or sum over MS if we write. So, if it is half, then other one has to be minus half. So, summation of MS will be 0, this also 0. So, the significance of the summation, so whatever summation we will get, so to get ML, summation of ML equal to 0, so L has to be 0, right. To get summation of MS, so resultant MS basically capital MS. So, this generally we can write capital MS, and this we can write capital ML. Okay. So, capital ML for resultant one. So, ML will be 0. So, that means L is 0. If L is 0, so ML will be 0, okay, capital ML for resultant one. So, similarly here only this one choice is possible. I cannot take this half and this for other one plus half. Okay. So, then all for both electrons set of this quantum number will be same, that is not allowed. So, in this case restriction is if it is 1, then other one has to be minus 1 minus half, if it is half other one has to be minus half. So, this total MS is 0, that means resultant S. So, S is 0. If S is 0, then only I will get capital MS, resultant MS 0. So, S equal to 1, that is not, that we cannot take, that we cannot accept. Okay. In this case we cannot accept. So, but S equal to 1, that will be allowed if any other out of these three, if one is different, like S2 2s electron in S. So, I have 1s 2s, I have 1s 2s. If one electron is here and another electron is here, that means their n are different. Okay. N are different. So, if n are different, so this can be same, MS can be plus half, both can be plus half. So, summation of MS, that will be 1, okay. Capital MS will be 1, resultant 1. So, capital MS is 1, if S is 1, then only we will get MS is 1. Okay. So, although it is S electron, but when this electron are in same orbit, okay, they are same, their n value are same, then only S equal to 0 is allowed, S is not equal to 0. So, we will get S equal to 0, and that is not allowed. Okay. So, from here already I have mentioned this S2, when NL value are same of 2 electron or other 3 electron, 4 electron, whatever, NL same. So, those electrons are called equivalent electron, and if NL either N or L or both are different for 2 electrons or more than 2 electrons. So, then this that electrons will be called the non-equivalent electron. Okay. So, for non-equivalent electron, it is the S equal to 0 and S equal to 1, both are allowed, because they will not violate the Pauli exclusion principle. So, for non-equivalent electron there is no problem. In straightforward, whatever this following the vector model, whatever L and S will get. So, that all are allowed, and corresponding is spectroscopic term we can write, we can find out. But when electrons are equivalent electrons, then it is slightly tricky to find out the allowed states, allowed spectroscopic term, as we have seen here. Okay. So, here what we are seeing here, these are obviously equivalent electron. So, for this case L equal to 0 and S equal to 0. So, this one state will be 1 S and J will be obviously 0. So, this is the 1 S 0 state or spectroscopic term. So, here you see this S2 is a closed subcell. So, for closed subcell, what I am getting? I am getting resultant L is 0 and resultant S is 0, and you can show for any other closed subcell the same result. So, for all closed subcells, so L resultant L will be 0 and S will be 0. Okay. So, one I have shown here. So, for P6 also the same D10 as well as for F14. So, this resultant L and S are 0. So, neon it has 10 electron, so 1s2, 2s2, 2p6. So, for neon it is closed cell. For helium S2 it can be helium 1s2. So, helium is for helium is closed cell, closed subcell. For neon it is closed cell. So, if subcells are 0, L is 0. So, for closed cell it will be obviously 0, because if you take vector sum of these all subcells, so it will give 0. So, so this one observation is that this for closed subcells or closed cell, the total angular momentum and spin angular momentum, orbital angular momentum and spin angular momentum, these are 0. Okay. Now, so then we will see for P-electron. For P-electron, let us, so I will erase this. For P-electron, so P-electron, say P1, and whatever it can be 2 or 3 or 4, whatever, does not matter. So, P-electron, say L1 electron L1. So, I do not bother if it is 1s2, 2s2 and then 2p1, because 1s2 already L is 0, I will not consider. 2s2 also it is L and S 0. So, I will not consider. So, only P-electron, if any P-electron. So, for lithium 1s2, 2s1. So, 1s2 that is L is 0. So, 2s1, so only is 1 electron. Okay. So, I have to find out this L and S for that. So, it is like single electron. Okay. It is like single electron, like hydrogen atom. So, that is why lithium, in case of sodium, okay, then potassium, all alkali atom, you will see that except the outer electron, this rest of the electron, L and S are 0. Okay. L and S are 0. Okay. So, that is why it is the whatever L, S and J will get, that is basically for the 1 electron. So, that is why I have mentioned you earlier that this spectra whatever we see for alkali atom, they are very similar to the hydrogen atom. Okay. So, for P1 electron, so here basically I am showing how to calculate the resultant angular momentum, either orbital or spin, and then resultant one. So, so if we can calculate, so for particular atom one can easily find out. So, for P1 electron L1 is 1 and 1 electron. So, S1 is obviously half. Okay. So, resultant it is 1 electron. So, its state will be spectroscopic terms. So, that will be P, S half, it will be 2, okay, and Ls, J will be half and 3 by 2, half and 3 by 2, okay, half and 3 by 2. So, it basically 2 spectroscopic term, one is 2 P half, another is 2 P 3 by 2. Okay. So, for P electron 1 electron, this is the state. Then if P equal to 2. So, 2 electrons are there. Now, already for one electron L1 this, S1 this. So, I will write L2 another electron 1 and S2 equal to half. Okay. So, here what we will get? I have to find out the resultant L and resultant S. So, resultant L, it will be resultant L will be from L1 L2, L1 plus L2 to L1 minus L2. So, L1 plus L2 is basically 2 and then L1 plus L2 minus 1, L1 plus L2 minus 2 up to L1 minus L2 we have to process. So, you will get 2, 1 and 0. Okay. 2, 1 and 0, L1 minus L2 is 0. So, I will get 3 L value, I will get 3 L value and S value I will get, S value I will get say S value I will get 0 and 1, 0 and 1. Now, here as I told, since these electrons are equivalent electron, I have to check whether all values are allowed or all combination of L and S are allowed or not. Okay. So, that we have to check. How to check? So, this L equal to 2, L equal to 2. So, for L equal to 2, what will be the ml value? What will be the ml value? Ml value for individual, so I have to find out. So, I have 2 electron. So, for 2 electron ml1 it will have 3 value is 1. So, plus 1, 0, minus 1, that is for ml1 and ml2. So, it can have also either plus 1 or 0 or minus 1, okay, plus 1, 0 or minus 1. So, that is ml value for individual electrons. So, now n and l are same. Now, 2 electrons, so there are the, so this first electron I can put at any one, okay, I can put at any one. So, I have to look, I have to look at it. So, to get L equal to 2, so for L equal to 2, for L equal to 2, what will be the ml value? Capital ml value? Capital ml value will be, capital ml value will be basically plus 2 to minus 2, okay, plus 2, plus 1, 0, etc. up to minus 2. Okay. So, maximum ml value can be plus 2, and that is only when this L is 2. Okay. So, but plus 1, ml value plus 1, it can be from L equal to 2, it can be from L equal to 1, okay, or 0, it can be from L equal to 2, it can be from L equal to 1, it can be from L equal to 0. So, that I cannot distinguish from which L it is coming. So, that is why for L and M, for L and S, generally ml value we take the highest one. Okay. So, here ml value highest is plus 2. So, then taking plus 2, how ml1 and ml2 are this, which value we have to choose, that way we proceed. So, here for ml value 2, for ml value 2, so that will come basically from sum over of ml. Okay. So, sum over of ml is to get to, it has to be plus 1, Ml1 plus 1 and Ml2 also plus 1. Okay. This is one, this is another, and then take their add them, then you will get Ml value basically 2. So, what does it mean? So, for Ml2 already I have assigned the electron this 2 electron, this Ml value, its value is plus 1 plus 1. So, now A and L are same equivalent electron. Now, Ml also same, Ml1 and Ml2 for these 2 electron also same. So, now Ms has to be different. Ms1 if it is plus half, Ms2 it has to be minus half. So, I have no choice for Ms. So, sum over Ms is, so 1 if it is plus 1 plus half, then other has to be minus half. Okay. So, it has to be 0. So, Ms is 0 means S will be 0, S will be 0. Okay. From S equal to 1 also one can get, S equal to 1 also one can get. Okay. So, this Ms value as a total. So, but here we are considering the individual Ms1 and Ms2 and finding out the summation of Ms. So, this basically that capital Ms, okay, it is 0. So, S is 0. So, when L is 2, so that means for this Ml equal to 2, so L has to be 2. So, L has to be 2. So, for this case, one case I got L equal to 2, then S equal to 0. Okay. So, then second one I can choose L equal to 1. So, when L equal to 1, L equal to 1, so maximum Ml, L equal to 1, maximum Ml will be plus 1 or Ml will be plus 1, 0, minus 1. So, maximum Ml is plus 1. So, it is plus 1, is plus 1 is 1. So, sum over Ml to get 1, to get 1. So, for 2 electron, if one is plus 1, another has to be 0. So, another has to be 0, okay, because 3 value are there available, plus 1, 0 and minus 1. So, if one is plus 1, then another has to be 0, okay. Then only we will get Ml equal to 1, and this Ml equal to 1, it comes from L equal to. So, it tells that maximum value Ml is 1. So, its L value will be 1. So, in this case, so these two are different, these two are different, Ml are different. Okay. So, Ms can be same. So, Ms can be same, there is no, it can be different also, there is no problem, but it can be same. Okay. So, in this case Ms, capital Ms is 1. So, its S has to be 1. So, in this case another we are getting L equal to 1, we are getting S equal to 1. Okay. Then next L equal to 0, when L equal to 0, when L equal to 0, so Ml is 0, Ml is 0, and now S can be either 0 or 1, that we have to check. So, this so Ml 0 means this either both are 0, either both are 0 or one is plus 1 and another is minus 1. Okay. So, if it is plus 1 and then minus 1, there is no problem. Okay. So, they are different, but I have to see whether both are same, it is that combination is coming in the picture or not. Yes, if both are 0, Ml1 is 0 and this Ms ML2 is 0. So, both are same, ML are same. So, this has to be different, MS1 and MS2 has to be different. So, in this case MS is 0, okay, total MS is 0. So, I will get next one L equal to 0, S has to be 0, okay. Okay. So, yes. So, these are the allowed value which obey the Pauli exclusion principle. So, for PS2, so for P2, the 2 electron, what will be the state? What will be the spectroscopic term? So, L2, L1 and L0 all are allowed. So, L2 means it is so let us take L equal to 0. So, it will be S, then L equal to 1 P and then L equal to D, okay. And in this case L equal to 2 and S L equal to 0. So, S are 0. So, in case of S, so S and D it will be S equal to 0. So, 2S plus 1 that will be 1 and corresponding J one can write in principle if you know LS. So, here LS both are 0. So, it will be 0 and D in case of D S is 0. So, L J will be 2, J will be 2 basically L plus S and P is L 1 S 1. So, J will be L plus S 2 L minus S. So, 2 1 0. So, it is 0 P 0 1 2, okay, and this multiplicity 2S plus 1 S is 1 is 3, okay. So, here these are the actually 1, these here 3 terms are there and this so 5 terms are spectroscopic terms are allowed for this and here you see the meaning of multiplicity. So, 2S plus 1 we generally tell is the multiplicity factor. So, here you see this is only one term, right. So, here it is 3, multiplicity 3 means it has 3 terms, you know, P0, P1, P2. Here it is 1, okay. So, it is only one term, only J value is there, okay. Here J value is 3, J value is there. So, it is 1. So, but other cases for in case of S you tell it is 2, but since only it is in S orbit only multiplicity we tell 2, but it has only one term, but in general except that one in general. So, this tells the multiplicity, it tells the how many terms are there, okay. So, yeah, so that is this is the for P2 we have found the these are the terms, okay. So, let me stop here, I will continue in next class. Thank you.